day everyone. The video that will be presented to you is a video made by my students in CE151 Building Systems Engineering. The video will contain all the lessons that they had learned through this term. Lessons that are important to further advance their knowledge in civil engineering. These lessons are important because they are the key foundations to the program that they had took. It will prepare the students for their other major civil engineering subjects. We hope you will learn a lot from this subject. Thank you very much.
Foundation. A foundation is that part of a building which is in direct contact with the ground and is the lowest part of a building structure. Its primary aim is to transmit and spread the loads dead and live from the building over a sufficient area of soil to avoid undue settlement because of the failure of the underlying soil. Foundations are generally divided into two categories. Shallow foundation is a type of foundation which transfers building loads to the earth very near the surface. Deep foundation is a type of foundation used to transfer the load of a structure down through the upper weak layer of topsoil to the stronger layer of subsoil below. Other types of foundation. Strip foundation. This is the most common type of foundation used or adopted in building 1 or 2-story building, and at most 4 stories on firm non-shrinkable subsoil such as gravel or laterite. It consists of continuous strip of concrete either in ratio 1:6 or 1:4. Types of strip foundation. Normal strip foundation is when the width of the foundation footing is not more than 3 times the wall thickness. Deep strip foundation is when the depth of the foundation is up to 900 mm. It is used especially in shrinkable clay soil to counteract the variations of soil conditions at different seasons. Wide strip foundation is used to spread the load over a larger area of soil. It is used in soil with low bearing capacity such as clay, marshy ground, silt and build-up soils. The concrete is usually reinforced in both the transverse and longitudinal direction. Pad foundation. This is an isolated foundation constructed of reinforced concrete to support columns and mostly used in framed building construction. They can be used to carry point loads, or can be designed so that the loads of the walls and the buildings are transferred through ground beams that rest on pad foundations. The pad foundation transfers the loads to a lower level, where soil of sufficient load-bearing strata exists. Raft foundation. A raft foundation is one which covers the entire area of the buildings, may extend beyond it. It consists of concrete that is suitably reinforced and up to 300 mm. It is best suited for use on soft natural ground, soft clay, alluvial deposits. Types of raft foundation. Solid raft foundation. This consists primarily of reinforced concrete slab, up to 300 mm thick, which is often thickened under load-bearing walls. Beam and slab raft foundation. This is like inverted reinforced concrete floor with upstand beams between the bases of columns. The beams collected the beams and slabs, spreading the loads over the whole area. However, if the surface of the slab is to serve as a floor, then the raft with downstand beams is used. Cellular raft foundation. This is mostly used in basement construction, and can be constructed either as buoyancy, basement or box raft foundation. Pile foundation. This is frequently used where the subsoil is poor or uncertain bearing capacity, of where there is likely to be appreciable ground movement, as with firm, or where it is necessary to transmit the building load through weak and unstable soil conditions to a lower stratum of sufficient bearing capacity. A good foundation should satisfy the following requirements. It shall safely sustain and transmit to the ground the loads dead, live and wind in such a way as not to cause any settlement or other movement, which would impair stability or cause damage to the whole or any part of the buildings or both. B. It shall be taken down to such a depth, or be so constructed as safeguard the building from swelling, shrinking of freezing of the subsoil. C. The materials used must be capable of adequately resisting any attack by sulfates of any other deleterious matter and chemicals present in the subsoil. When it comes to design, foundations are designed to have an adequate load capacity with limited settlement by a geotechnical engineer, and the footing itself may be designed structurally by a structural engineer. Parts of a foundation. 1. Footers. These spread the weight coming from above, preventing the weight of the house from pushing the walls deeper into the ground. Footers are typically 2 feet wide, running the entire length of the wall, and 8 inches thick. The depth of your footers depends a lot on the type of dirt you have. 30 inches below ground level, for homes that don't have a basement, is fairly typical. They are always reinforced by rebar. 2. Stem walls are short walls that carry the weight of the home down to the footer. Stem walls can either be made of poured concrete or cinder block. Stem walls are needed whenever building on a slab or building with a crawl space. 3. Slab is poured concrete forming the floor of the home, or the floor of the home's basement. Slabs are typically 4 inches thick and reinforced with wire netting, called remesh. 4. Basement walls are just what they sound like. They also act as the stem wall of the foundation. The step-by-step process of constructing the foundation survey and stake-out footprint. This step is generally completed by a professional surveyor, who will come out and determine the appropriate distances from the property lines. This ensures that the building will start out correctly and to code. The corners of the building will be marked using surveyor's stakes. Then the surveyor will place offset stakes about 2 feet out from the surveyor's stakes. The digging for the foundation will be done using the offset stakes as the guides. This allows for extra room so the exterior foundation walls can be worked on. Excavation. A structural engineer will be needed to determine the depth of the excavation. All surface soil needs to be removed to expose the soil that is compacted enough to bear the weight of the building. The depth will vary per building. The top of the footing must be below the frost line, as this prevents the concrete from cracking when the freeze-thaw cycle occurs in the soil surrounding the building. Footings. A footing is a poured concrete pathway that is used to spread the weight of the building from the foundation walls to the soil. They are wider than the foundation walls that they are supporting and form the perimeter of the building. In some instances, there are additional footings added inside the perimeter to support load-bearing wall subslab. Generally, plumbing lines are run from the street to the building's basement by going over or even under the footing. This is even the case for buildings that have their own individual sewage facility or drain field. These lines are covered with a poured concrete slab. Foundation drainage system. Subsurface water is collected and moved away from the foundation to prevent pooling water or flooding. The foundation drainage tile is made up of an uninterrupted run of punched drainage pipes that have been embedded in gravel along the foundation of the building. In some regions, a sump pump may also be required to help collect the subsurface water. Walls. Foundation walls are poured concrete. They are poured using sets of forms that support the freshly poured concrete along with the appropriate bracings and hardware. Once the concrete walls are set and have achieved full strength, the formwork is then removed. The thickness of the foundation walls will be determined by a structural engineer. The engineer will determine the thickness of the wall by calculating the height of the wall and the load that the wall has to bear. Anchor bolts and beam pockets. Foundation walls need anchor bolts to secure the framing of the foundation. Anchor bolts are embedded in the concrete at predetermined points along the top of foundation walls. The structural engineer will have already determined where the anchor bolts need to be prior to the walls being poured. Beam pockets are embedded in the top of foundation walls as well. Their purpose is to receive, support and hold beams in place. Waterproofing. A waterproofing sealant is applied to all of the exterior foundation walls that are below grade. This is why the excavation of the foundation left room beyond the perimeter of the actual foundation. The sealant helps to stop water from coming in through the walls and into the building's basement. Slab. A 3 to 4 inch thick concrete slab is poured between the foundation walls. This will help stabilize the base of the walls. Backfill soil. Once the foundation is completed and the waterproofing seal is dry, backfill is pushed into the trenches around the foundation walls on the exterior. Some will backfill a third of the way with gravel, and then top it with soil that drains easily. Backfill provides stability to the building's foundation.